Howdy everyone, and welcome to the tutorial video for Chapter 7. We'll be looking at balancing reactions and applying solubility rules. Really, that's what the whole chapter is about. So it's only going to be one problem and a few parts of it, but with that one problem, we're going to hit all the key details from Chapter 7 that we need to know for our homework and for our test. All right, so we're going to get right to it. It's going to be here, problem 7.63, parts A, B, and D, I believe. Where they give us two reactants for a double replacement reaction, and they want us to first predict the products. What will the two products be over here? Balance the reaction, and then apply the solubility rules to say, will it be aqueous, solid, liquid, gas, whatever. And so we're going to do that. Double replacements you'll see a lot because they are the most common form of what we'll call the precipitation reactions. Where we'll get a lot of the application for solubility rules. There'll be test questions that say, if you mix these things together, will there be a solid, or what will the solid be? And so being able to do the problem, this is how you can answer so many questions in both homework and test. The nice thing about double replacement or double displacement reactions, they're also called metathesis. They have a bunch of names. But they follow two key patterns. The first pattern is that the cation for one compound in the reactant, so in this case the potassium, will always pair up with the anion of the other, so it'll pair up with the sulfide, and then the barium cation will pair up with the iodide anion. So that's the one pattern. Just remember the pluses go with the minuses. The other nice thing for double replacements is that the charges do not change. So if you can figure out the charges of the ions on the reactant side, they will be the exact same charges on the product side, and you can just do your normal crisscrossing of charges from Chapter 5 to say, well, what will the formula be to then help me balance? And so what I'd like to do for that is to go ahead and write the charges up top of the reactants and then just carry them over to the product side. So I would look at the periodic table and say, okay, here's potassium. It's an alkali metal, first column. It's going to be +1 because it loses one electron. To be like the noble gas argon. And then iodide, it's a halogen, it's in column 7A. It's going to be -1, gain one electron to be like a noble gas. Barium, based on where it is at number 56 there, alkaline earth metal, it's going to be +2. And then the sulfide, where number 16, it needs to gain 2 electrons to be like argon at 18. So it's going to be -2. And at this point, take a second to double check your answers. Make sure that these charges make sense with the formula. If I've got 2 and 2, well, yeah, that would cancel out to 1 and 1, and that's what we see. 1 and 1, 1 and 1. So it just kind of make sure that, yeah, does it make sense? That means you probably labeled it right, and now you're ready to move on to the next bit. So we're going to take those pairs, right? Potassium, now going to pair up with sulfide. So I'll put a potassium +1, a sulfide -2. We'll crisscross the charges, and we'd say, okay, the first product is going to be K2S. I'll put a blank in front for balancing, and then I'll just put a little parentheses there that I'll fill in later with the solubility. All right, so that's our first one for just crisscrossing. Then we'll do our second pair, where barium will go with iodide. So barium is going to be +2, iodide will be -1. When we crisscross those charges, we'll have BaI2. And again, we'll just leave a little blank for our solubility. All right, and so at that point, we've got the formulas down. Now we move on to balancing. So here's where we'd say, okay, let's write down every element we have, count how many are on each side, and then see what needs fixing. So we've got potassium, we've got iodide, we've got barium, we've got sulfide, and on the left we have 1 of everything. On the right it's 2, 1, 1, and 2. So we can see, okay, the K and the KIs need help. Well, here they are together, that's great. We'll put a 2 in that blank, gives us 2 and 2. Now everything checks out, everything matches up. So that's it for balancing. These other ones, when you type them in, you'd leave them blank. But if it was a test question that said, what's the coefficient in front? Well, it would be a 1 for each of them. All right? So balancing is done. Now we're just on to the third part, where we apply the solubility rules, say, well, what should we write here in these parentheses? All right? So for the first one, we go one product at a time. we'd say, okay, here's potassium sulfide. Potassium's an alkali metal, and the first rule I gave you was that if you have an alkali metal or ammonium, it's always soluble, no exceptions. So I don't care that it's sulfide. I got potassium, it's an alkali metal, that is going to be aqueous. That's going to be soluble no matter what. We then move on to the barium iodide. Barium gets mentioned in a couple rules, but as exceptions for various things. So we gotta, say no. Okay, I don't know about it yet. I gotta check what it's with. It's with iodide. Iodide and some of the other halogens, chloride, bromide, iodide. They have the rule that they're usually soluble, except with silver, lead, and silver, lead, and mercury. Well, barium's not silver, lead, or mercury. It's not one of these exceptions, so that would also be aqueous. So this would be this balanced reaction. Now there is a weird thing on this type of homework problem that might come up for if you have I think 64 on the homework set, where if everything's aqueous, well, that means it's not really a double replacement reaction, it's just mixing. Remember that a double replacement reaction needs to form a solid, a liquid, or a gas, and this didn't do either. So while this is what you should type in and what you would write up, officially for the computer, you would type in no reaction because you didn't form a solid, liquid, or gas. So that happens sometimes with these homework problems, but that's the steps. That's what you got to do to double check and make sure it's no reaction. All right, let's move on to B. We'll do the same process. We'll figure out, the ion charges first. I've got a +1 for potassium and a -2 for sulfate, and yep, that checks out with the formulas. I've got +2 for barium and -1 for bromide, and yep, that checks out. When we switch partners here, we'll have potassium +1 with bromide -1. One each is KBr, and we'll just leave it blank. We will then have barium +2 and sulfate -2. So again, 2 and 2 cancels out to 1 and 1. So BaSO4, and leave it blank. We'll check the balancing. We have K. SO4 is the same on both sides, it's sulfate, so we'll just leave that as SO4 sulfate. We have barium, we have bromide, so we have 2, 1, 1, and 2, 1, 1, 1, and 1. So here the KBRs need help, so over here we'll put a 2, and our balancing is done at that point. You will notice with double replacements, not all of them, but you get a lot of ones that are like 1, 1, 2, 1, or 1, 2, 1, 1, or 1, 2, 2, 1, stuff like that. Nice, easy ratios for the most part. So balancing's done now. Now we just got to figure out the solubility. We have potassium, and just like part A, potassium's an alkali metal, always soluble. You could also look at the bromide and say bromides are soluble except silver, lead, and mercury, and potassium's not one of those. So either way, you say it's soluble. It's going to be aqueous. Right, we move on to barium sulfate. Barium, again, we don't have a specific rule. We got to look at the sulfate. Sulfates are soluble except for strontium, barium, lead, and mercury. Oh, there's the barium. There's the exception that makes it insoluble. So this will be a solid, and that means, yes, this is a real double replacement reaction. We formed a solid, liquid, or gas. So this is what you would type in. K2SO4 plus B aqueous plus BaBr2 aqueous goes to 2 KBr aqueous plus BaSO4 solid. Right? And then we'll move on to one more, part D, where we'll do the same thing. We have sodium acetate. Sodium's +1, acetate's -1. We have lead nitrate. Now, this one's a weird one. Lead is it's not a transition metal, but it is a metal that could have more than one charge. So we kind of double check it, just like we do with figuring out Roman numerals for transition metals. We say, okay, I don't know lead necessarily, but I know nitrate. That's a polyatomic I know about. It's -1. Because there's 2 of them, that adds up to -2. So what does the lead have to be to cancel that out? Well, it's got to be +2. I just saw that the aqueous here is missing, so I'll go ahead and write that in. Right. But now that we've got our charges, let's go ahead and switch the partners. We've got sodium here. We've got nitrate. We have 1 and 1 when we switch them. NA, NO3, and we'll just leave a blank there. Then we'll go ahead and add, okay, we've got lead, which is +2. We've got acetate, which is -1. And when we switch them, Pb parentheses C2H3O2, and then a 2. And then again, we'll just leave a little blank there for the state of matter. Now we'll balance it to make sure it's good there. So we've got sodium, we've got acetate, so just write all that together. We've got lead, and we've got nitrate. And so we say, okay, there's 1, there's 1, there's 1, there's 2. Over here, there's 1, there's 1, 2, 1. Okay, there we go. Wait. Did I do that right? Yeah, I did that right. All right, and then we go through and say, okay, we got to fix one of these. Just pick one. I'll go ahead and fix the nitrate first down here at the bottom. So I'll need a 2 in that blank. That gives me a 2 there, but also a 2 here. Now to fix these, okay, I'll put a 2 in the first blank. That's a 2 and a 2. And then now everything works out. So that means this must be a 1, and that must be a 1. And there's our balancing done. And now again, we'll go through and do solubility. The sodium, it's an alkali metal. It'll always be soluble, no exceptions. A nitrate for the anion, that was one of the anions that was soluble, no exceptions. So again, if there's 2 rules that could apply, they will always agree with each other. So both say soluble, AQ. Now we have lead acetate. And acetate, again, even though lead has a lot of exceptions where it'll make something insoluble, acetate was one of our ions where it said if it's acetate, it is always soluble, no matter what. So we'll put an AQ there. And so this would be another one where, yeah, we did all that work, and what we would write in on the computer is no reaction because we didn't form a solid, liquid, or gas. But, again, that's the process. Whether you form a solid or not, that's the process you will do each and every time. That's how you balance reactions. That's how you check charges. That's how you check solubilities. So when you're doing these problems for most of Chapter 7, I know there's not too many of them, but that's what you got to keep in mind always. Am I switching the ions together correctly? Did I remember to get the formula right before I go to balance it? And then did I check my solubility rules correctly? Did I apply them correctly to see if it's solid, liquid, gas, or if it's going to stay aqueous? All right, so I hope that was helpful, and I will see you guys back again for Chapter 8. Take care.